Hello there, Algebra students. This is Mr. Kashi speaking. This is our first video on Chapter 10, Section 2, which is graphing quadratic functions. We're going to spend 3 days on this lesson. It's very important to know how to graph quadratics. It's the main standard in Algebra 1. And this video we're going to go through what standard form is all about and how to find an axis of symmetry. So first of all, you've seen this before. Standard form. I just kind of want to go through what each letter does to a graph. So this first one, A, is going to tell us one, whether the parabola points up or points down, and it's also going to tell us if it's going to stretch or shrink vertically. And just kind of a review from last time, if this A term is in between 0 and 1, it is going to shrink. So if you have like a 0.5 in front of the x squared or a 0.2 in front of the x squared, it's going to shrink. If A is 1, then that's going to be our parent function, okay, just our standard shape. And then when A is greater than 1, we're going to stretch. And that would be the same for on the negative side of things. So if it's negative, it just means that it's pointing down. And then if it's between 0 and -1, it would be shrinking, pointing in the negative direction. And then if it's greater, or if it's less than -1, then it would be stretching in the negative direction. So hopefully that'll kind of bring back some of the concepts from 10.1. B is what number is here is going to tell us how much it slides horizontally. Okay, and obviously that's left to right, and we're going to go through a bunch of examples of how that looks when it slides left to right. It's a little bit hard to kind of predict when it slides left to right, but that is what determines that B term tells us if it's sliding left to right. And then C is how it slides vertically. And this will be up or down. And C is pretty easy to predict, because when it's positive it slides up, when it's negative it slides down. With the B terms it gets a little bit more difficult. It's not only opposite, but it slides left to right in a weird way that we're going to talk about a little bit later in this section. But I just wanted to clarify what all of these letters meant to what was happening to our parabola. So we have this thing called the axis of symmetry, and parabolas are symmetrical. Means that whatever happens on the left side of their median, it happens on the right side. So there is an equation, a very small equation, to determine what the axis of symmetry is, and that would be what we say opposite of B divided by 2 times A. And you will be able to take that from standard form. So if we had our standard form here, ax squared plus bx plus c, we would just take our b term and our a term. Doesn't really matter what our c is. Our b term and our a term, and we'd plug it into this small little formula to find out what our axis of symmetry is. And what the axis of symmetry is, just defining it, is a line that splits the parabola in half. Okay, and if we had a parabola like this on the right hand side, I'm not even going to do the equation for it. I'm just going to draw a vertical line that splits this parabola in half. Okay, and as you can see, this would be the vertical line x equals -1. And so you can see how it's at -1 right there. And we know it's the axis of symmetry because if we had this point on the parabola and this point, you can see that this distance is the same from the axis of symmetry. So this would be the same distance from either of those points on the parabola. So it just splits the parabola right in half. And when our vertex isn't on the y-axis, it is important to find this axis of symmetry first, because then we can graph our parabola starting with where the vertex is. So our vertex is always going to be on our axis of symmetry. So I do want to go through one example here, and we're going to find the axis of symmetry, draw it out, and then we will graph the rest of the parabola. So here we have an A of, sometimes it's easier to list out what we have for our terms. Over here at the right, I'm just going to go A equals, B equals, and C equals, even though we're not going to be using C. A is 1. Technically, there's a 1 in front of that x squared. We just don't write it. B is going to be 2, and C is going to be a negative 1. Now, we're not going to use C to find the axis of symmetry, but we'll obviously use C in order to graph the parabola by putting in the values into the table. So remember, it's opposite of B over 2A, so it's going to be opposite of 2, which is a negative 2, divided by 2 times A, which is 1. So we can simplify that to negative 2 over 2, which is a negative 1. So here our axis of symmetry is x equals negative 1. Now that is very, very important for two reasons. One, we are going to draw our axis of symmetry right on our graph like this. Okay. And in the previous lesson, we were just writing in some standard numbers, negative 2, negative 1, 0, 1, and 2, because our vertex was on the y-axis. Our vertex is not going to be on the y-axis now. So this number needs to go in the middle of our graph, right here. That needs to be a negative 1. Okay. This will save us a lot of time and work trying to find the points on our parabola. So then what I would do is I would go 2 values before and 2 values after. So I'm going to go negative 2 and negative 3, and I'm going to go 0 and 1. Okay, so you'll hear me say this a lot. After you find your vertex, or your axis of symmetry, you're going to go 2 before and 2 after. That's very important because our parabola is symmetrical. This will save us some time and some work down the road. So we're going to bring down our expression here, x squared plus 2x minus 1. Now, because we have this in the middle, and we always know when we have our vertex in the middle of our table, these numbers are going to be the same right here. So this is important to know to save some time and some effort, because I would rather plug in the 0 and the 1 here rather than the negative 2 and the negative 3. So that's what I'm going to do. Instead of going from top to bottom, I'm going to go from bottom to top, and then I'll be able to just record the top 2 values here without actually having to do the work. So here we'd have 1 squared plus 2 times 1 minus 1. So 1 squared, that would be 1, plus 2 times 1, that would be 1 plus 2, which is 3, minus 1, which is 2. Here we have 0 squared plus 2 times 0 minus 1. So 0 plus 0 is obviously 0 minus 1. See, that was much easier than plugging in the negative 2 and the negative 3. Here we'll plug in negative 1 squared plus 2 times negative 1 minus 1. Negative 1 squared would be 1 plus a negative 2. That would be negative 1. And then we would have another minus 1, which this would be negative 2. So now we don't have to do the last 2 at the top. We can just record this as negative 1 and 2 as our values, okay, because it's symmetrical and because we found our axis of symmetry and put it in the middle. So we can go ahead and plot these points. our vertex is going to be on our axis of symmetry, and sure enough, -1, -2, it's right there. Okay. If we were to go in the negative direction here, we have -2, -1, and -3, 2. Then on the other side, it should be symmetrical. 0, -1, and 1, 2. So it should look like that. We can finish the rest of our parabola like that. Okay, so obviously you can see our parabola is not on the y-axis. Our vertex is just one step over to the left. We didn't stretch it at all. It was the same shape because we have a as 1. But we're able to kind of slide our parabola to the left 1 and down 2. And we're going to go over some more examples in the next video on how these different numbers are going to manipulate our parabolas and how they translate from side to side.